Tomorrow is kindergarten gravity lab.
All right.
Now we have a plastic bin full of paper and tissues and bouncy balls and ping pong balls, and I put in a paper airplane. We're going to figure out why things fall as fast as they do. Now, try not to use the word hypothesis. Speaking of kindergarten words.
John, we need to get set up. When my daughter was in, I guess it was first grade, there was the teacher at the time had a regular thing where you was take heart time, you go in. She's got like all these donated things like kitchen appliances and all that kind of stuff. And you went in and you, at that time, parents were actually allowed to volunteer in the school. I remember, actually, so there's two separate things. There was that was fun, but they had me in to build motors. We built paperclip electric motors.
Oh, yeah.
And I did the top of the right hand.
You can
Paperclip electric motor.
yeah, you basically you wind the paperclip around the battery the right way, and the wire will spin around.
No, this is building up from paperclip.
Oh, the full thing.
Yeah, building up little armatures. And
okay. Because there is like a very small proof of concept that uses, that basically treats the battery itself as a wire, and the paperclip becomes the electromagnet.
No, these were not them.
That's good.
These were little motors that we built on. Yeah, you need to.
That's better because I can bring up.
Well, you have to. And what you do is what you'll do is, it's our pizza. Hey, me too. Yeah.
And then you put the rotor on.
Gathered this.
Blah, 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 blah.
Yeah.
Oh, cute. Okay, so we got a magnet, paper clips, and what's on the bottom?
That's the battery.
Oh, the battery. Okay.
Essentially
So John, what you need to do is you need to go into the handout that I sent you, and you need to share. So you
Share my
go into
screen.
presentation mode, share into the handout.
Just got your email. Where are you?
I'm a subtle person, aren't I? So today's special feature is, in addition to the pizzas, we have stuffed shells.
Mm. Not good for the diet, but probably tasty.
Well, it's not my job to watch out for people's diet, though.
I know, given that you can eat 4 of those bags of Doritos and not appear to gain anything.
You didn't use up more calories eating them than consuming.
Yeah, I think you
So
use up more
stuffed
calories
shells are gonna go
breathing
fast.
than most people do.
But does he get oranger when he eats the Doritos?
No, that's a good question. That's a good question.
I don't know. I saw him preparing for the drive home, like,
Oh,
Oh, yeah.
yeah,
It's like
stocking up for
packing up
3.5 hours.
Yeah, it's like how can you
It
eat all
gets
of those
boring.
in a day?
Yeah.
Yeah.
I mean, I often stop
If you
at
take the stuffed shells, only one stuffed shell a piece.
I often
Stuffed
stop at like
shells.
Target or
I'm gonna go
Starbucks
get
or
her
something.
So only one a piece.
Fancy.
With lastly,
Or should I be
What's
doing
that?
something? Is this for-
you need to go to where my link was that I sent you. No, you went to the event thing, but that only works for me.
See if I read your email on that.
Yeah, or if you've been on Skype. Okay. No, I've read.
Got it.
Going in. Okay, now, what you need to do is, I should see you in here. Oops. Okay, looks like,
I can enable things.
right, so you need to share, so the little thing over to the side,
I see what you did there.
you need to share your presentation screen.
I enjoyed there's a lot of barbecue sauce. There's more than barbecue sauce than last week.
It's a little slow.
Yeah, it's doing it, it's doing it.
Yeah.
It's slow. So
I'm
now,
gonna close some things to make it.
the key to successful TWed presentation is to eliminate the entry.
Eliminate the entropy. I like that. Okay, now let me mute. All right, 1 sec. It's just a little. I'm sharing something with CMAPS, which is freaking it out, so I gotta stop that. Go away. Share entire screen. I think that's what's happening. Okay. It's not responding, sorry, here. I think it's doing something in the background. Yeah. Kill things. Kill things. So that. Kill this. This. Oh, I know it may be. Now it's alive again. Alive. Okay. Go to my presentation. Presentation will present. Okay. We're good. You do. We're not working. Okay. Do I need to mute anything, or is it for audio? Yeah, let me do that. That's what I thought. Yeah. I am muted. Back. Okay. Yep. Okay.
I'm in the category of the user TWed, and I switch between what you're sharing and the camera.
Ah, okay.
So I kind of.
You're the producer.
I'm the producer.
Director.
Okay. So what happens is, this is the mic that will be. So this is.
Keep that somewhere.
Yeah, this is my mic, and
All right.
I'll use that weird.
Okay.
Don't worry about that. It's just sometimes
You're the director. Okay. Okay. Kill what? Screensaver? Oh, like a power saver thing? Okay, let me do that. my power savings to never stop anything. Once you get to the environment, it'll work. Yeah. Yeah. They get to it. Yeah. It actually is very bad. Right. Thought I was. No, I'm not. That good?
Are there multiple speakers on? Or microphones?
What made you think that?
No, we're just actually doing this TWed from a different dimension pattern. But think
Oh.
yeah.
Well, if it's a different dimension, then can you transport me a couple pieces of pizza?
Oh, and we have shells.
Oh, that's right.
In this dimension, all the pizza is conceptual.
Damn it.
This is. Oh yeah, that'd be good.
Patrick, look at my camera.
I'm looking.
All right, enough of this hooliganism.
I guarantee you get better pizza in Boulder.
This is pretty good pizza, though. We switched from Big Apple to Fasio's, and it's been.
It's much better than it was.
They are.
So let's doing it. Let's get started here. So welcome to the nth TWed of the spring 2016 term. We may want to open up that back door at some point. It's
Better now.
our wonderful first warm day of the term. We're welcoming John Sheehan, PhD student here. Are you a computer science PhD?
Computer science, yeah.
Computer science PhD student, and who's been with the lab now for 2 years.
2 years.
And John's going to talk about. We'll get into what John's going to talk about. Just a couple logistical notes. Today's TWed is being streamed and being recorded as usual. We have remote participants. We actually, as you heard, we've got Patrick West on audio, so he can chime in with questions at some point. You'll actually hear him. Usually Patrick watches, but he doesn't usually question. But he's the issue of workflows and workflow provenance is of interest to him, so he may actually have a question. So just keep in mind that it's being streamed. Please start signing up for the end of the term lightning talks. If you go to the announcement message that I sent out for this talk, you'll see at the end, I think the one I sent out either this morning or yesterday actually has the link to the lightning talks. It's actually the same spreadsheet as the sign-ups, but it's a different tab. Please start signing up. I'm going to start pestering. There is no TWed currently scheduled for next week. That's not because it's break. I'm not that kind. It's just I did not schedule it. So
I have one logistical thing. So I'm encouraging everybody to come to the Mark Fox talk on Friday, and I'm wondering if somebody can set up so that we can do remote.
Ray can do that.
Okay, so you can do. Oh, you already set up a Google Hangout or something? Okay, perfect. Thanks.
So maybe we'll have some reminder announcement that will include the Hangout for that. Is it a Hangout or a Hangout on here? If you want to stream, well, we'll talk. So, it says John Sheehan and John Erickson. Most of the talk is going to be John Sheehan talking, but part of the reason that I'm on there is I'm very passionate about this notion of workflows. Personally, I've I first became aware of this notion of scientific workflows as a thing almost 10 years ago. I was working at HP Labs, and we were our web services lab, whatever we called ourselves. We were starting to explore different kinds of systems that would end up content-centered collaboration systems that would end up being hosted in this thing that we ended up calling the cloud. And the idea was,
What year was that?
ancient times.
Okay.
It was almost 10 years ago.
Okay.
I'd estimate it was 2007, I think, is when we started thinking about this. This idea that there would be a new way that work was done. People would want to collaborate around common pieces of content that were hosted exactly as we do with Google Docs and those sorts of things now. And one of the things that we had in mind was that we'd want to, for certain tasks, you would want to follow some sort of structure. And that when we were authoring a specification, for example, you would want to, there were certain steps that you would want to execute. Certain people with certain roles would need to execute that. When certain people completed those roles, something would happen. A notification would be sent. But this is these sorts of things are implemented by something called a workflow management system. And at the time, there was some emerging from the business community, but there was one in particular that was fascinating. It was coming from science. It was Taverna. John's going to talk about Taverna as an example of a scientific workflow management system. But it's there's things that are interesting about workflows. If you know anything about scientific workflow management, there's it's obvious that you want to document them because of the what they've done, what they've executed, the functions that were performed on specific pieces of data, what the conditions were for that. But what we don't often talk about is what is it supposed to do? Okay, what is at a high level, what is the purpose of this workflow? At a slightly lower level, what are the different component pieces of that workflow? What are they supposed to do? What is the description or what's the recipe? That's something that we're now understanding due to recent things happening at the NIH. Our attention is being drawn to. Scientists are being asked or mandated to document how their processes and methods will be reproducible, explicitly reproducible. How don't just write about it in your paper, but provide evidence of what you did, the processes you executed, data that you did it on, that you proposed to operate on and actually operate on. So how are you going to accommodate that in the execution of this project that you're proposing? This notion of rigor and reproducibility that John will talk about. So we are in the lab exploring ways to add these concepts and work that we can contribute to proposals that we're writing actively right now. And so this is a long way to say this is wicked important. Thank you for being here. Take it away, John.
Okay, John, thank you. And I want to share John's enthusiasm because to me, and this may be a little grandiose, you're taking that special expertise that we all have in things that we may not always realize. It's like that X factor when we just sort of remember from our own experiences, I know how I can solve this particular problem, or here's an approach that I usually use to deal with this. And yet, we rarely ever have a systematic way to capture that so that we could share it in a kind of a rigid, analytical kind of way. So scientific workflows in and of itself probably something that we could do an enormous amount of research in, and how to capture provenance and how to share, but maybe it could even go beyond scientific workflows. Like, I guess it's been considered for things like business and medical and so forth. So I think it has enormous implications. I'm very excited to work on it. I definitely want to credit John because he brought me into this and really got me going on it, showed me how to use some of these tools. A lot of the information I'm sharing came from John, and also from the Semnex team, Professor Bennett and two of her PhD students in particular, Hannah and Alex, and Professor McGinnis, of course, had a lot of input into this as well. So I'm just going to kind of share with you where we are with it so far, but maybe even more importantly, where we're hoping to go with it as we move forward. All right, so I'll start with just some motivation, why it's so important. I just learned in our meeting earlier this afternoon the reason why it's even more important than I realized. It affects potentially the funding for projects, and that's obviously going to get a lot of attention out there. So that's one reason. But there are other benefits. Well, there I am too.
Just make sure you
Says I am screen sharing. Maybe
push
just
forward.
bandwidth.
Go to your slide.
Okay.
There it is.
Slide hiccup. We're okay. Okay. And then just give you some overview of what scientific workflow representation really looks like. It's a flow chart, essentially, is the way I see it. And then getting into more interesting stuff. How can we actually represent provenance using these workflows? And we'll find out there's actually been a lot of work done in this area as well, so we can leverage it. And there are tools out there that have been used. John mentioned one, Taverna. There's others that can be used for actually generating provenance from a workflow. And the one that I've been kind of using in particular is Yes Workflow. So I'll give you some feel for how that works and how we may be able to use that to do what we're interested in doing moving forward, which is taking that YesFlow tool and generating extensions that can create Prov1 compliant RDF. So what we want to do is capture the workflows and store them in an RDF format. And then the applications are numerous, and there's a lot of ideas here. I'm sure you have ideas too, so after we get to that point, you want to chime in with your thoughts, what we can do to move this forward. So the thing that we were talking about at the meeting earlier, and clearly is going to get a lot of attention, is the fact NIH, I learned, is the biggest funder of these types of projects that we're doing. And so promote greater scientific rigor and also, transparency in funding applications. That's going to get the attention of funders because they don't want to reinvent the wheel. They want to be able to fund a project and have it leverage and share work that's already been completed. So one of many reasons this is very important is this idea that if we can somehow automate this or somehow store these workflows, that we could use it to justify funding for studies and projects. So one of NIH's new objectives is for scientists to actually present these workflows in formats and mechanisms that will facilitate better reproduction. And what better way to do that than to leverage some of the semantic technologies that we're all using here. And also, it's not just about the data and the code. That is a relatively trivial thing, to reproduce. What we're really trying to get at is, like I said earlier, that secret sauce, that recipe, that intuitive thing that we all have in us when we come up with solutions to problems. And how great would it be if scientists could, share that and leverage it. So that's what we're attempting to accomplish with this. The entire analytical workflow is really needed to be able to make something reproducible. So what do we mean by that? Comments that scientists may make as they go along, descriptions of computational blocks, specific parameter settings. So they're describing their algorithms. And in order to make this reproducible, it has to be done in a fairly rigorous manner. And there are tools already out there that can do this, but what we're looking to do is make it even more rigorous. So in order to facilitate that, we know we're going to need new things. We're going to need new ontologies that can really describe these workflows and make them more shareable and repeatable. Definitely work needed in that respect. And also successfully creating the methods and practices that will provide new capabilities to leverage and reuse data analytic workflows on future problems. So we really want to use these tools to be able to do that as well. So why not use some of the semantic technologies we already have out there? That's really the point.
John,
Yeah,
if you could just go back.
Absolutely.
Before we leave this, there's an important point about reproducibility, particularly in the kinds of projects that we're talking about with NIH, National Institutes of Health. It's not as much about reuse, or reuse is an issue, but it's actually about enabling the reproduction of the experimental work and the analytical work. And when we're talking about workflows, analytics work, we're talking about the analysis. It's about replicating those results as a measure of the validity of the science that was done in the first place. Mm-hmm. Okay, so when Francis Collins was speaking about rigor and reproducibility, the rigor part is making the sound scientific argument for the proposed work. Reproducibility was ensuring that in everything you do, in all the records that you're keeping, you're doing it in a way that enables other scientists to precisely replicate those results. And there's lots of reasons for that, from the scientists who have done work for malicious intent to simply ensuring that the work is accurately being redone. The communication of the science. Oftentimes, a journal article is not the best way to communicate a process. Sure. There needs to be something more. So that's really probably the most important thing about reproducibility is that aspect of it. Okay. We've been operating in computer science often because the nature of the work is trivial to reproduce something, but oftentimes in these biomedical works, they are doing work which is at least as complicated as creating novel code. But that code, which their publications depend on, is okay. And that's really the heart of it, is that. So,
Great.
Proceed.
Okay. So here's some examples of how these scientific workflows can be represented. And I think we're going to show you some of the tools in a moment that were used to create these examples. But I see them as, flow charts. I mean, that's my kind of impression of them. Logical steps with looping wherever necessary. And, in some cases, you can pick a particular piece of the process and sort of zoom in and see it in greater detail. So there are lots of tools that can be used to do this kind of thing. Basically, what we're going to look at is a few of them and then dive into the one that you see here on the right, which I believe was generated with workflow. At least it looks like it. And show that as an example for how this can work. So this is what we're talking about when we mean scientific workflows. And systems to do this kind of thing have existed for some time. This is not new. The ones I think that we looked at were the last 5-10 years anyway. They've been out there, maybe longer. So some examples. So there were, kind of two ways that scientists typically do this kind of thing. In general, they like to do scripts. And they usually like to use languages like Python, Perl, or MATLAB, or R. And the most comfortable way that I think the majority of scientists currently are doing this kind of work is they're creating these scripts using one of these languages. But because of the increasing requirements to track the workflows, they often use a separate tool to be able to generate the workflow diagrams. So they might be using Python, for example, but using something like Wings or Taverna for the workflow. And of course, the odds are when you have two separate tools and extra work, things are going to slip through the cracks. So one of the, I think, problems with using one of these tools was that scientists had to do the script and then use a separate tool to create the workflow.
So there's more to it than that.
Yeah.
Okay. So for three of the systems on the left, Provenance, Kepler, Pegasus, those actually came out of a big science infrastructure project from early in the 2000s called the grid. Okay, and it's the notion of the grid actually preceded the cloud, and it was this idea that scientists would construct complex computational workflows using computation services distributed around the internet. And so tools were needed that would allow the scientists to create the structure of the computational flow that they wanted using components that were remotely located. So, and even data. You know, the grand Ian Foster's grand vision for the grid was data would be distributed, computation resources would be distributed, workflows, the scientists would construct workflows, and they would be executed. So so tools such as Provenance, Kepler, and Pegasus were constructed so that you could compose them visually together. And one thing I wanted, you said this a couple times, and this is not to criticize, but this is not about, you can't think about this as just about the diagrams. Right? This is about documenting. The diagrams are an offshoot. They're the offshoot of what's being done. They're documenting what's going on. WINGS is a unique one because it was specifically designed to work in a kind of a semantic way. Pegasus, if you've been paying attention to big science for the last couple of weeks, Pegasus was actually a workflow system that was used by LIGO, the Laser Interferometer Gravity Observatory, which just recently confirmed gravity waves. And that's cool because my daughter worked on LIGO. But so the systems, all except for WINGS, were kind of coming all the way back to reaching back to the grid and composing on a component basis. Whereas, as John said, these familiar tools on the right are easily accessible tools to scientists to create these scripted workflows. And I think you got to be careful about saying they prefer to work that way. A lot of scientists do work that way. Yeah. I think that's the better thing to say, because there's like a lot of scientists who work on the other side. Yeah. Because they want to or have to. Right. Okay? But we all know MATLAB.
So one thing though is that if you're talking to the NIH, you're missing one of the workflow tools that's actually used most in biomedical research, and that is Galaxy.
Yeah.
Okay.
And so that should get added on here. I'll put that in the notes. And also in the notes, there was a question saying, where does Yes Workflow fit?
Yeah, we're going to kind of lead into that. So to answer your question, the interesting advantage that Yes Workflow provided is you can actually generate tags directly inside the scripting language that you're using, whether it's Python or MATLAB, etc. And Yes Workflow has the capability of extracting a workflow representation directly from the script. You don't have to use a separate tool. You can do it all from inside the script. And I'll show you a couple examples of that in a moment.
Yeah, so I think you addressed these.
Yeah, I think we had a couple more slides going into this. So, okay. So I think actually, John, you may have kind of hit on this already too, but why are these so useful? It's actually a requirement in many cases, as we said, to create and manage and exchange workflows and review results. And these tools were really designed to help simplify this whole process. So the more we have common language tools that we can share, the better we can have ways of sharing work. I guess a key thing too is provenance. Provenance traces, having ways for scientists to investigate workflow execution and show how they correlate reproducible results. So these are all reasons why I think these things are used extensively right now. Some of the problems that the tools can create, as we kind of alluded to, these are all specialized tools, specialized environments. It may take some time to learn how to use them. There may be needs more than one. Different scientists may not be using the same ones. Many scientists implement complete workflows using scripts, as I mentioned and John mentioned. So this is like an added step for them. And neither SWS nor scripts communicate descriptive aspects of the workflow. So I think there's more semantics behind it all, I think, as you alluded to, John, than just a diagram that we're really ultimately looking to capture more than just a single flow. So these are all some of the limitations. So this is where obviously semantics can play a huge role. So we can use all kinds of different semantic technologies to help describe these workflows, to help share these workflows. We can use things like OWL, RDF, and Sparkle, for example, which is what we're looking to do more with, to describe these inputs, these computations, these workflow steps, and basically represent all of this in some kind of graph where we can then take advantage and leverage all the tools that we have for using RDF for those purposes. So we can do reasoning, and we can do automated workflow completion. There's all kinds of things that could be capable if we got into a mode where we put these into RDF format. And so far, at least to our knowledge, Wings is the only tool currently doing that, John. Is that correct?
Well,
that we're aware of?
So Wings is the system. Some of these other aspects, the reasoning and that work, is Yolanda Gill's team is doing a related work. So if Wings produces the workflow models, their areas of research for them are these other aspects. And it's I mean, really what's amazing about the group that's doing Wings is they're bringing the full power of semantic web and the research related to semantic web to this question. And so that's that's what's novel about it. It's not an offshoot. It's not. In the case of Taverna, there are ways to get provenance metadata out of Taverna, but it's not built from the ground up for this purpose. Wings also has some really novel uses of semantics in its design. For example, you construct a workflow. When you describe that workflow, you model the nature of the data that you that the workflow is designed to consume. And so when you build or plan, it's called planning the workflow. It only shows you the data that it knows about that match the type of that. So you're not, which is pretty marvelous that it's this type-based notion of constructing that workflow. It creates a workflow plan, which is expressed as a graph, and then when it executes that, it's all of the intermediate results as you go through the workflow execution all have URIs, and they're all accessible. In fact, as it's executing, you can get it sometimes. So it's so there's many cool aspects about it. The dark side, there's two dark sides. One is that that it requires you to use that framework. Okay. What if I like to do my scripts in R? All of them, all together. Why do I have to fragment them apart? That's one thing. You'll touch on that. But number two is it doesn't capture. It focuses on what was executed and not what was. Not the descriptions. There's no way to comment stuff. As far as we've been able to find. So there's a whole sort of knowledge about what it's supposed to be doing, what the workflow is supposed to be doing. Is okay. And they acknowledge that.
They do. Did somebody send an email or you?
Yeah.
Okay.
Yeah. I tried to break it.
Okay. Okay.
Sorry. Go back to your cage. All right.
Okay. So in conjunction with all the other semantic technologies, the one that's particularly interesting in this case is Prov1, which I guess is a fairly recent extension of Prov that's used specifically for representing workflow
it's an
provenance.
offshoot of the Data One project.
Oh, I see. Okay.
The provenance working
Yeah,
with data
well,
partners.
I mean, it's certainly an update to Bravo, which is from the World Wide Web Consortium, and it's largely funded by, well, people who are funded by Data One have contributed greatly to this, but some other people who are not funded by Data One have done this too.
A little jewel that was produced by Data.
So this in particular, I think, is something we want to look closely at. We'll get to that in a bit. So we'll talk about Prov 1 because one of the things that a lot of the papers, like in particular the yes workflow papers, talk about is these different kinds of provenance. And the fact that we're really actually interested in all of them in different ways. But I think we kind of agreed it was best to stick with the definitions of provenance that we found. This is coming from, I believe, the Prov 1 overview that was posted on the line. So first concept, I guess, that is probably key to this is what we call prospective provenance. And the best way to think of that is it's the recipe. It's the specific steps that have to be carried out for a scientist to generate an artifact. So that in particular is obviously really important if you're going to share your secret sauce, if you will, with the rest of the scientific community. We need a, efficient way to capture and store that type of provenance. There are other things that matter too, though. Retrospective provenance, which is the steps executed in the generation of the data artifact, recordings of the base inputs and intermediate data artifacts involved, and information about the associated environment. So in the case of yes workflow, there's ways that you can do both prospective and retrospective provenance. Excuse me. And there's, I think, a value to both of those. There's also the idea of process provenance, where the steps, often trial and error type steps, by which the process is used to create the data product itself is designed. So how does the scientist actually produce the data product, and what are the steps that they take to do that? And then the actual structure of the data, which we're going to see that as well in yes workflow, how both the data is used and produced by a computational process, and how it's organized and represented. So we're basically looking at it in terms of like inputs and outputs. And part of that is the data flow, I guess.
What's unclear from this, so this is Prov 1.
Yeah.
Okay. And Prov 1 is a very nice description, but nothing does this right. Okay. Some things need to be parts of it, but nothing does this, and nothing claims to do all of this. Some of these, like for example, process provenance. That's like metadata concerning your iterations of the tool. Okay. So as we move forward, one of our objectives is to think about. So I'm not saying that they have provenance vocabulary for all of these aspects, but part of the work that needs to be done is to how to apply these models in real life workflows and the processes generally in the workflow. How do you properly annotate a script as you're revising it?
And how do you do it in a consistent way? So if you and I do it, are we going to generate something similar?
Well, this is exactly it. And maybe, so one kind of scientist, one scientist within, or analyst within one particular domain may share scripts in a particular way. They may structure them in a particular way, they might comment on them in a particular way, they may use packages in their MATLAB or R code in a particular way. So there are certain practices that have to be documented, certain ways to apply these models to that, whereas others may do it differently. So there's nothing beyond the abstract in terms of how to do this, and tools are, except for in the case of retrospective provenance, which is what was done. Okay, there's a lot of precedent for documenting what was done. Wings, for example, Provenance, for example, they do that. Right. You'll probably mention no workflow, which is a way to. And Lin Young, if you remember when Lin Young did his defense, one of the things that he talked about was hooking the kernel. That was a space I don't know if he actually used no workflow, but he was hooking the IPython kernel. That's an example of capturing retrospective provenance. Yeah.
Does process provenance capture changes in a workflow or changes to a workflow?
The process of changing the workflow. So for example, you might, here's how I think about it, is if I have a big R script and I make an important change, like I decide to include multiple imputation here. Okay? You asked about workflows, I'm talking to you about workflows, okay?
Using
But, so
workflow I'm not familiar with, so
so you're going to introduce a code block.
Okay.
You've decided through this iteration, you're going to introduce a very important code block. Okay? The prospective provenance will capture the fact that it's there. Okay? As we understand it, process provenance will capture the changes that you changed it in this iteration or took something away. So that when you, at a later time, and you try to understand more about this workflow, how this workflow came about, you'll see that document. So some of this is very familiar in terms of when you look at the history in GitHub or whatever. Some of this. So as you look at changes, tracing changes, you might think of that as an example of process provenance. That's kind of that space. There's not a lot that's talked about old for Prop 1 to try to enter that space. Yeah. So it's an interesting aspect, and we got our work cut out to kind of model that because there aren't best practices. So that's your question.
So yeah, I mean, like the S workflow one, I think really, to my knowledge, is just prospective and retrospective.
Well, I don't even know. Yeah, I'm not convinced about how it's covering retrospective.
Yeah.
I mean, I don't know how it's doing that.
Yeah.
It doesn't.
Yeah, that's
So
what I thought.
it's really prospective.
Well, so it yes workflow. You might wonder this. Jonathan hasn't talked about it yet.
Yeah, maybe I should get to
talk
it.
about this in yes workflow.
Yeah.
Yes workflow is the opposite of something called no work. We'll go back.
Well, that was the next slide anyway, so we're right on.
So yes workflow is a response to something called no workflow, which I mentioned before. No workflow is actually a framework for capturing the execution steps, the retrospective provenance of a workflow that's implemented in, say, Python, without doing it. Okay, so it's like, let's turn it on, let's execute our Python script, let's have this record of what was done. That is, no workflow is meant to hook the kernel and provide that. The no meaning, I don't have to do anything special, it just does it. Yes workflow was in response saying, I don't have any description of what's going on. I know what function, what code block is executed, but I don't know what it was supposed to be doing. I don't know why it's there. There's so much I don't know. I don't have a summary of this workflow. So,
yeah, I mean, I think the great innovation of Yes Workflow is simple enough an idea. Hey, why don't you just add the comments directly into your scripts as you're going along? It uses a scripting tag similar to java.commenting that you can use to capture basically all the key things that you need to generate the workflow. So instead of having a separate tool where you go in and create these workflow diagrams, you simply put the annotations into your scripting as you go along, or you can do it after the fact. And it works with most of the typical scripting languages like MATLAB or what's that?
You can do it before the fact.
Wouldn't that be ideal?
No, you can't. No, I'm not kidding.
No, I'm agreeing with you. Yeah, adding the comments after the fact, never a good thing, but we all do it sometimes. So the idea is you simply use these scripting languages, and I'll show you the syntax in a moment. You can add things like showing data inputs and outputs. You can add like blocks for the diagrams that it generates. And then it's a fairly simple tool. It just runs it sort of like a compiler and extracts a pretty nice looking diagram. I'll show you some examples of it. So the Yes Workflow tools and they have different options for how they do it. Can produce this graphical output that you can then share. You know, creates like PDF files,
So
stuff like
Patrick,
that.
did you have a question? Go back.
Yeah.
Patrick, did you have a question?
I have a question. Well, actually, I have one comment first. Slide numbers. Slide numbers. That's the comment. Okay. Question. Can you go back 2 slides? Oh,
Yep.
one more slide. 1 slide. Sorry.
You got it.
Okay. Provenance in my mind is retrospective. So saying retrospective provenance seems a little redundant. Prospective provenance, I don't get. I mean, prospective means these are the steps that are likely to happen. They could, but they don't actually. They might not. And provenance is this is what happened to get from point A to point B. So I'm a little. What does prospective provenance mean?
Prov plan.
Yeah, it's the plan, right?
Okay, so it's prov plan, but it's not provenance. It's the recipe that could be followed.
Yes.
Yeah, it's the intended recipe.
It's what you stick in prov plan. Yes, but it's not provenance.
It's not provenance in itself.
So, well, okay, so there's an orthodoxy here. We set you up. You didn't know this was going to happen. Yeah, and actually, Stefan Zednik brought this up on Monday, as I was discussing this in the meeting, and he said, there's no such thing as prospective provenance, blah, blah, blah. And I told him what the problem would be with things. There's an argument about that provenance is very strictly just the documentation of a record of what has happened, what has happened, what has done what to what, what has done what to what in that whole space. Okay? And within Provo, there's one little thing that says, actually there's 2 little things, there's a plan, and there's a has plan.
And it's an empty shell.
And it's an empty shell. It's beyond the purview. The Prov group believes that's They believe that what prospective provenance describes itself as, and we're not making this up. This is the whole Prov 1 group, which is some very respectable people. Say no, it's a thing. Okay, and it goes like this, and it's the description of this very important stuff, which must be documented. The debate is whether this is prospective provenance is a kind of provenance that fits under this thing, and is what Prov 1 says it is an extension to Prov, or is this some other thing? Okay? And I haven't seen. I know that the arguments are going on, but I haven't seen it percolate up, and I've asked for links to email threads about the argument because we want to obviously know about it.
So
Deb wants to know about it, so she doesn't get crucified when she talks about it.
right. So
Yeah.
my position on what you're calling prospective provenance is that it is an ontology of possible future provenance that doesn't exist yet. So activities and entities that may exist in the future. And therefore so anything that you say about things that will have happened, you need to phrase in terms of classes of things that are subclasses of prop classes. And anything beyond that is kind of extra. It's outside the semantics of prop. And so sure, Prov 1 can talk about things that happen, but you're not going to say it in a way that has anything to do with what Prov says. There's no relationship there. But if you view prospective provenance, as you're calling it, as the possible world that might exist if certain activities took place, then then it's tied to prov. It's tied very closely.
And so this is so this is a challenge. It's a challenge to close that gap in where you're suggesting. Okay? Because what the content that prospective provenance is using to create this is very descriptive, and sometimes it only obliquely has a real tie to, you know how comments are in code. Okay? Sometimes the comments are quite precise, and sometimes they're, and I'm doing this. Okay? And it's very difficult to, I would suggest, to meet the requirements that you just set. Okay? To really tie them together. This is the goofy human in speech that was referring to this competition block. So, so I'm, I don't want to go down a lot of depth here. I just want to point out, teach the controversy. Now this is there's two sides that are coming at this right now, and we don't have a solution for it right now. And this is one of the things we have to figure out.
So here's an argument, right? So you're working on some code on a project, you're branched off, and you're changing the code, and you're just working on it, right? But you haven't committed at all. I imagine this prospective provenance is sort of everything that you've done up until you hit that commit button. And then once you hit the commit button, people actually see, and it's committed, and then people actually see what has changed, the provenance has changed, right?
No.
Now there's a new A to B. But before that, all the changes that you have done, the previous A to Bs, I don't see anyone actually seeing
The
that.
provenance doesn't exist until you run the code.
But this hasn't even run.
I know.
That's
so
what I'm
there's
saying.
provenance.
So I'm saying that, like, the example here where if I want to capture this is not necessarily useful for people who are maybe down the line that want to know what happened A to B, where data went from A to B or something like that, or a process went from A to B. They're on the other side, not the consumer side, but the developer side, whether they want to know how you decided to put A to B, and all that stuff gets lost when you say commit and they don't see the previous changes A to B.
Right. So you're talking. Well, that would be provenance of an artifact of software.
Right.
So that's a separate issue from what we're talking
It's actually getting to the sort of to the process provenance that they use, which is also, I mean, so at least the process provenance is talking about how we got to this point. Okay?
Yeah.
But the prospective provenance is essentially script comments. I mean, that's really the scientists refer to it as recipes or plans. The prov people, after much debate, decided to call it plans. But now you're on your own. So I'm just going to say, I want John to move on, but I'm going to say that we need to figure this out. You know, it's and we're going to have to reconcile. And I totally understand the arguments, despite what I said with stuff in Monday.
Well, and actually, I was just doing searches. So it's been around as a phrase for at least 7 years.
Oh, yeah.
I've been finding, and it's not just one community. So it's not just OPM, it's not just Bertram. It's kind of a number of places.
Yeah,
However,
but you got some zealots there.
yeah, well, this is not surprising that people have different perspectives on this.
This is why we pay them whatever bucks we pay them in creating intelligence standards. Go ahead, John.
Okay.
Sorry.
No, it's a very interesting point. So I was just going to give you like a quick example of how Yes workflow can be used to create the workflow. So what you're looking at here is a script that's been annotated.
I'm sorry.
Go ahead.
Yes workflow is not creating.
It's creating the diagram.
It's creating a pretty picture and it's documenting.
My mistake. Yes. Sorry. Yes. Workflow diagram.
Well, that's what it's all about, isn't it? No, that science is creating that workflow.
Correct. It's generating the diagram representing the scientist's workflow. So it's showing you can see in the upper left corner inside the script, all of the tags that have comments in front of them with @begin, @param, @in, @out. Basically, those are the things that the scientist needs to add to their scripts in order to generate this diagram. So I do think one of the challenges is it does require the rigor of putting in the tags correctly. And John and I have played with this tool. We know some quirks if you don't put them in the right way. But each of those begin and ends are representing blocks, and you can see from the lines when you do run this through the compiler for Yes Workflow, it will create a diagram similar to this. So in this case, the input mass file, input data file are coming from those two lines here with the @in tags. I don't know if you can quite make out the text on this, but it's pointing to specific files. And then you can see each block subsequently, fetch mask, load data, each of those coming from those various tags. So that's really the whole innovation of this Yes Workflow tool, is this idea that just by commenting your code using these tags, it can build these diagrams for you. Now, when you do run it through Yes Workflow, there are actually a couple of different views that you can create. What you're looking at here is what's called the process view. So that's really just the green blocks showing the flow, starting from input mass file and then with result and there's also a way to rerun it to pull what's called the data view. So now we're looking at the same script, the same tag, the same annotations, but pulling in a different view.
Also,
Yeah.
what's actually being done is the Yes Workflow code parses the source file, and the same markup is being used for whether it's Python or R or MATLAB. You just use whatever the syntax is for comments in those particular languages. And then it's creating a Prolog XSB database or model of the workflow. Then you run a kind of a query against that model to generate these different kind of diagrams. So each one of these diagrams is a particular Yes Workflow command, which is partially a query into this Prolog database to assemble what you see here. So this is I just want to be it's not sort of running and creating the diagram. It's the Yes Workflow is run to create the model, and then you run queries against this model. They just look like command lines like anything else. Queries with certain parameters set produce these different views on this. So the way you construct this is, and also if you've got, what's not shown here is if you've got nesting, there are particular ways to navigate the nesting. In the model, the Prolog XSB model, it preserves the various layers of nesting of the computational blocks. There are ways to query into that. So it's kind of a sophisticated thing that it's doing. It's creating this logical model.
Yeah. If I remember right, there was an issue with the nesting. I think you had contacted them. And then
right, yeah, it's just an issue of how it's displayed. Right. And how to ultimately, how to properly represent it in this perspective coding.
Great. So there is also a combined view, process and data view. So now we're looking at the same script again, but we're combining the two views that you saw earlier, and you can see how that gets generated. Should I bring up like a live example real quick, or just stick with slides? Okay. And for those of us who can't see so well, there's a very big picture of some of the annotations, just so you can get a clearer view of the kind of text that we're talking about. To me, it was very much like java.com, and that's what I saw when I first looked at this. So you get a sense of how it works.
So there's a couple of things. So one of the things that's happened is impact that we've already had on the Yes Workflow code base is they don't really have a way of, it's in what John's showing here, of describing a particular step. You can see here the beginning of a computational block, whether it's the main program or this intermediate thing, fetch mask. There's no way to describe what fetch mask is doing. They added an act description tag to their language. So you can have, we might have had an example of that.
I think we used it in the example.
So you can, so in addition to just having the stupid name, you can have an actual description without underscores as white space that's describing what that computational block does, and it gets into the metadata. It goes into the metadata. There also are examining, wouldn't it be nice to have a URI associated with each computational block? One of the conversations that we're having with the developers is to do those sorts of things. So it's quite exciting to be working with these guys and have some impact on them and have them react to that.
Okay, cool. So,
Quick question.
Oh, go ahead.
Back a slide.
Yep.
So these annotations within the code is generating the workflow, right? We haven't touched provenance yet.
No, the script is the workflow.
Right.
The script is the workflow. What these annotations are doing is essentially generating a particular logical model
of the steps that could be taken.
Of the structure of your workflow file. Okay?
Oh, okay, I got it.
So think of it as think of it very much like putting the annotation in that's going into RDF. That's exactly what's going to happen.
That's really
What it actually does is it produces Prolog tuples, and that is the Prolog database. So it's producing, and it's got all the interconnections. All of what you see in those figures that John was displaying are produced based on all this tagging that's happening.
Right.
Okay, that's what the extraction process does. And there's a couple different levels of the model that it does. Kind of the entities and how the entities are connected together. It's pretty rich and it's very powerful. And the pretty pictures are only the tip of the iceberg of what can be done.
So I know you can't read this one, but just to explain the story, we took a script that was created by one of Kristen Bennett's PhD students, Hannah, and it was a project that they were doing as part of the Gates Foundation work that we're doing called the CPP project, Collaborative Perinatal Project. So this script was written by Hannah, and John had sent it to me. What I did just to kind of get a feel for how this YES workflow tool works is I added the annotation. So I took her code, went through it, added some of these various tags that you can see, and then, MATLAB in that case, yes, and was able to generate a workflow workflow diagram. Donald, get me if I don't say that. From this, so it's actually pretty cool how it worked. Once I get the hang of some of the little quirks to it, it worked quite well.
So this is
Hannah's script. Yeah.
So there's a perfect example of.
So read that. I can't read.
Yeah. So what it says is, so the computational step, the name of the step was fixing AppGar.
Oh yeah. Okay.
Fixing
and that was a big deal.
Okay. And well, what's fixing AppGar? Okay. Fixing AppGar. Some AppGar scores were way above the average in the 20s. Okay.
Well, and further, they were way above the top score that was allowable to be a value for an AppGar score.
So until we have this addition added, we couldn't say that we just set.
Yeah.
But now it's now it can be captured. Some of this is like creating a tensor and that sort of thing, but they instantly did this. And we asked for this, and it was with less than 24 hours. They had that in there because they saw that. Because otherwise, what you're doing is you've got computational blocks that are a mile long, trying to capture the information. So,
that interesting thing too, the wording of these descriptions. Those are Hannah's words, not mine. I was able to use Hannah's existing comment, but by using that annotation, have it captured. I think that's kind of an example of how this can really capture some of the provenance in the workflow.
And then further, you could imagine connecting this into Wikipedia or something.
Sure.
It says, what are the terms in this? That's a free text block. You know, you can
Yeah.
imagine trying to hook that into an ontology definition for some of these terms. Like, what's APGAR? I forget what it is.
And the one that John's showing here doesn't have, well, there's certain things are being shown. There's there's parafact, there's Siemens clustering, this one didn't have the, this didn't have the imputation, but the one I did had the imputation. The particular method of imputation. But somebody's got to explain that.
Right, so you can actually just look up APGAR. So that was a person actually who invented some scoring strategy. But you could connect in.
Yeah, definitely.
So what you see here is most of the semantics of this workflow would be lost. You didn't have this means of extracting it. So,
another thing I think is interesting when we worked with Hannah, we kind of asked her to explain and describe the thought process that went into creating the script. So without something like this, there's a lot that gets lost, doesn't get captured.
So
you do something like that.
Someplace I'm on this thing, and now I remember that. So APGAR scores are only allowed to go up to 10, and they had a bunch of scores above 20. So, and I thought they had that captured, how they fixed it.
Yeah, it's probably in the script. It's my guess. I don't remember offhand, but.
So what she's asking for is how do you see that?
Let me check that.
So I actually don't remember
I think they subtracted 20.
No, I know how they did it. That's what they did. So what I'm actually, the question I don't do is can we see that? I don't remember whether that's in the pre-processing. I mean, John's got it here, but I don't.
I think it was silent before, and because I had to present this to Gates, and they quote cleaned their data. I'm like, well, what did you do when you cleaned your data?
Yeah.
So I had to like pull it out of people's heads.
So I'm kind of curious where. So the script. So John's script, what he did was the actual sort of processing.
Yeah.
He did the analysis that ended up dumping out various things. The script that I did was called Yenner Tensor, which was following Buell's advice, doing all this magic that created the thing that actually got computed. It was the basis of this computation. And there are all sorts of addresses in that. Anyways.
Based on the script I looked at, it looked like it had been a copy originally of the Yenner Tensor script. So
yeah, she
there
did
was
a
stuff.
site.
Yeah.
She had a monster.
It was a big script.
She commented this, didn't comment this. It's two different things.
Some funny comments in that too. All right, so this gets into the, where do we go from here stuff, which is really the exciting part. So the Yes workflow tool that we just showed you, that's been out for a while, but there's a new extension which is really just in development. It's certainly not complete. And John and I worked a little with Tim McPhillips, I think. I actually worked on this with John to explore the idea of taking the output, which, as John mentioned, the actual output that Yes Workflow creates is XSB Prolog. It's like a flavor of Prolog. And those are basically like what they call data log queries like you see in the diagram. And if we had that, would it be conceivable that we could do the same but put it into an RDF representation? So the vision, and we've actually played around with this already a little bit, is to take both the data log query representation that Yes Workflow generates and somehow incorporating Prov1 to build a RDF representation of the workflow. If we did that, then we would be able to do things like run Sparkle queries. And I think what Tim did is he took just a few of the canned data log queries that you can generate from Yes Workflow just to play with, I think. Experimented with converting those to Sparkle and running those against some hand-generated RDF that he did.
Right, yeah. The important thing is the stuff, the data log query and the Sparkle query, that's just, that's sort of gravy. The important thing is the production of the RDF, right? Okay, so you create the RDF, then what do? You query against it. he had a set of queries that were extracting specific information from the prologue,
Right.
and he created equivalent Sparkle queries to do that. What I was able to do is so he generated RDF for a particular workflow. I just dumped it in the triple store and just did arbitrary queries and just SPO kinds of things just to have fun with it. To do you don't.
I have a slide on that. If you want to show that. So again, very difficult text to read, but just that on the left-hand side is the original Python from one of the examples that Yes Workflow had in their GitHub. And what you see on the right is a manually generated.
I don't believe that.
Well, he said by hand in one of the emails, but maybe I guess.
I think what it was I think he created some kind of hand queries.
That makes sense. Yeah. That makes sense.
He didn't write this RDF file.
I would think so. Yeah.
That's why I've been bumping so often.
Oh, okay. So somehow he did generate this and he posted it. There's a section in the Yes Workflow GitHub where they have this. It's called the RDF extender or generator, I forget what we call it. So anyway, there is the capability, or at least it's been tried, to take what normally gets generated by Yes Workflow in the form of data log and instead represent it in some form of RDF, which is what you're seeing here.
So that's what problem RDF looks like.
He did use Prov1. I know that he had said that John, you had referred him to Prov1 and he used it somehow.
Yeah, he hadn't seen it before.
Yeah, so I believe he did.
So this is
read it,
an approximation of Prov1.
Yeah.
So one of our objectives, and I think John gets to this, is number one, automating this.
Right.
Because it's a prologue model, it's a perfectly legitimate model. We just need to write the code to dump out the RDF and do it compliant with Prov1. Then what we need to do is make sure that we're producing legitimate Prov1. The markup standards match what the intentions are.
So this is the thing I'm so stuck on.
Yeah.
The authors of Prov1 will be the first to admit that it is an initial attempt at something like prospective provenance that is very naive, and if this is at all accurate, has very little to do with Prov in terms of its relationship.
Which ties to your original comment.
Exactly. So I don't know necessarily if we want to target Prov1 specifically in the way that you're doing it. Simply because, one, it's going to change. Two, it's inadequate. And three, there's a research opportunity here to do something much, much better.
So, yeah, yeah to number three, but we best not do number three without checking number one. Without going through one and two. My point being is we would not be doing our job if we just set our problem. We don't want to do that. We need to validate the statement that your assertion that it's preliminary, and you got a couple of choices. You can either work with them, or you go your own direction.
Well,
you do something entirely different. Maybe we don't. We call it something else. Maybe it's the workflow ontology.
Yeah. My guess is that's taken. But
so Jim makes a very good point. But I think as far from a collegial standpoint, we don't assume that it's bad. We recognize the fact that it's
well, no matter what any of us do, it's rare that it can't be improved. I'm sure they'll all agree that their stuff can be improved. But we should identify what the weaknesses are that we're trying to address.
Yeah.
And if you have particular ideas about the way cooler things to do, we should definitely be exploring them.
Well volunteered.
I've been mentioning them for 2 years.
Well, which aspects of this?
Activity classes as plans.
So,
I can bring
So-
this up over
so
and
there's
over
more-
and over
so-
again.
there's more depth here.
Yeah.
There's much greater depth that we can explore. Okay? But and I don't want to belittle what you're saying. This is exactly why we're doing this. And as Ray knows, these talks iterate. They get to much greater depth. Subsequent version of it.
Okay. So I think this kind of leads into further directions, what we're kind of thinking about. So supporting scientific domains, just demonstrating the impact of using semantic workflow representations, maybe applying it to one of the projects here in the lab like Cheer. Enhancing insight, discover and highlight the related workflows, problem statements, statements of methodology, algorithms, source data sets, all those things to individual workflows and vice versa. And imagine that we could somehow find a way to find similarities now. Two workflow scripts might be discovered to be similar, not just for very mechanical reasons, but for really semantically interconnected. And maybe scientists can really discover things that they never realized before when they're sharing each other's work. But as John said, we got a lot of work to do before we get there. So we just started discussing, ideas for how to do this RDF generation from the data log queries of Yes Workflow. I think that's the piece I'm going to start trying to work on next. And then test the Prov1 model as we just described too, for how well it would hold up to be able to do this.
So yeah, I think what we're going to want to do is add a both to that previous slide and to this. I think we do want to take Jim's advice on strategically how do we want to kind of approach this. Let's approach this from what needs to be there. It's not necessarily a problem.
Yeah, and you're also not solving the problem yet.
Well,
I would argue, solving the problem. What do you mean?
Well, so by the representation that you have, you have no sense yet of kind of what problems you're going to be able to solve with it. So obviously, you're not going to be able to tie it back to actual provenance of run data because there's no way to do that with Prov1, and there's no way to track the provenance of a script that's annotated with Yes Workflow to generate the provenance in the first place.
Well, do I care about that? Maybe I don't care about that. I don't know. I don't have to care about that.
But so I don't know what what the problem is here yet. Yeah. What are we trying to fix? What are we trying to solve by having this first place?
so we want people to be able to share their workflow. So take Kristen. She got a quote methods paper from our epidemiologist friends at Winslow. And so she got some data sets, and she got a methods paper, which is supposed to tell her everything that she should know about being able to replicate the results. And she's scratching her head; she can't replicate the results. She didn't actually get the R scripts, but her claim is that even if she had the R scripts, that wouldn't be enough. So we want to have the description enough for a trained person like Kristen to be able to say, I'm going to be able to replicate these results.
So
Like writing a
extraction.
script of their own based on the idea of the representation of extraction from the script that was run.
Yeah, but probably also getting some tool support to do that. But first, what do you say? She said essentially she can't reproduce the results. And actually, they mentioned the CPP project. So Kristen has been doing data analysis for, 25 years, and Bulent, who's been doing data analysis for 25 years, had the same data sets, same problem, predict child's IQ. And they got kind of different results. And they kind of cleaned their data a little bit differently. They imputed missing values a little bit differently. And then they used actually pretty darn similar approaches. But Kristen, for example, cleaned up the Epcot scores differently than Bulent did. But that stuff is all silent. So how do you know whether they've got comparable results or not?
And so being able to, in a structured way, extract these semantics and extract the structure of these workflows and do different things with them. Put them into a knowledge graph if that's appropriate. Maybe the pretty picture is an important thing. Well, if Buell's able to flash up the structure and Kristen's able to flash up the structure, and you can look at them and go, we're different here, and we thought we were doing the same thing. There's the workflow discovery. Imagine being able to discover a workflow just based on, I'm looking for something that's got this sort of outline.
I think I know the answer to this question, but I think especially if this is going to other people, the how is what you just did going to solve those reproducibility, discoverability problems? I think that's something that is not clear from what's up there or what any of you three have said. I can guess because I know the domain, but that doesn't mean that I should be guessing. Doesn't mean anyone else here guesses necessarily.
Well, I in partial defense of that, I would say just because it's early days.
Well, yeah, but you have to have a vision of how. So we're doing X, Y, and Z, and it's cool stuff, but you have to have at least a high level conceptual idea of how what you're doing now is actually going to solve those problems. You have to have a plan about that.
So this is exactly the comments that I was writing at 1:30 a.m. last night on the white paper. Like, okay, I was trying to glue it together, and I did part of that, but it's not as clear as it needs to be.
And it's at a high level. So the answer to that is things like, well, once we get text descriptions of it, we can do full text search on those descriptions. That's really great. But you can do that with just indexing the comments. So how is this better?
How do you get the comments?
You parse the comment lines. I mean,
How do you do that?
Well, you look for. I mean, that's actually a pretty trivial task to do because you syntax. I mean, syntax highlighters can do that.
Yeah, but so they can, although I don't think any of these tools do it.
Well, okay.
How do you preserve the structure?
my-
How do you preserve the structure? How do I know which
Yes,
block
but
is that?
what
How do
you're
I
worried
preserve
about
the
is-
nesting?
what
How
you're
do I
worried-
capture the nesting?
What you're worried about is discovery. You don't need to worry about the nesting.
How do you?
I don't know. How does nesting solve the problem?
So I
of
want to
discoverability
throw
and
out that.
reproducibility?
The nesting of a workflow
You don't
is not.
I'm not sure you know yet how representations of nesting are going to solve the problem of reproducibility. You might have a vague sense of it, but you haven't even communicated the vague sense of it. And that's my criticism. Nothing, basically just that. It's connecting the dots at a high level. And I see the dots. I just don't see the lines.
So right now, I've recently seen a project where they're releasing a new system. It's marine biology, and they can dynamically generate these heat maps to correlate microbes in the water, and they can generate interesting graphics dynamically, like pie charts and other things. Thank goodness Peter's not here. What ends up happening is that. So I asked them the question is basic. So okay, so you can generate this dynamically, and it's really useful. It's really cool, and the marine biologists are jumping up and down here and moving. But the question was, how do we tell people how you made it? Right. Specifically, what data sets did you use, and what if you got it at this time, then what workflow were you going through? Were you going through version 2 of the software, and now you're 3 years down the road and you upgrade to change that? So they have a configuration file, and that's how the scientist working on that client saves their current image to then later get in the future. But then does that mean that whenever you publish this image, that you just need to include this configuration file so that anyone in the future that wants to know how you get this image or also is interested in your data and wants to get your data sets needs to have this image from your publication, or you dynamically generate an RDF graph through your workflow that you then include a single link in a footnote that says this is the URI identifier for this image splash page provenance follow. Go as deep as you want.
So yes.
Yes.
Yeah.
Is that a thing? That's a thing, right? That's the thing we need fixed.
So
Well, kind of. You know,
Yeah,
basically,
yeah.
you need enough breadcrumbs to be able to do it again.
right, so you describe several things. you describe the use case for reproducibility, and some of the um, ways in this particular domain they're achieving that reproducibility. Providing some insight into how it's being done, not necessarily a lot. A config file which enables them to reconstruct it, to rerun it, is not necessarily the same thing as being able to access the description of the actual analytical recipe that's used, the plan that's being used to do that computation. It's not the same thing. Okay? A blob of code that you send these parameters to this code and you get this output. It's not the same thing. It's explaining what that code block does. It's not.
Right, I agree with that. I agree with that.
And nor does it help me find it. Okay? Well, if I'm looking for a particular analytical script that does a particular thing or uses a particular way, that's a use case for workflow discovery. How do you do that? There's lots of different ways you could do that. You know, Jim's perfectly right. There are ways that you could just throw workers in a particular domain to throw their scripts into a thing and you can index them and you can create models of them. And in some sense, that's all that this is. It's just a clever kind of markdown it's giving hints to an index. Right? And that's one possible way out. But the point is of the perspective learning stuff is to get at some insight into what's going on inside, not just the retrospective. And that's not to say that the retrospective aspect is unimportant. That's obviously what was done when with what is a very important thing. But it's not the only thing.
Right. But, so
it's a thing.
It's a thing. I think that you're going to need, especially for reproducibility, if I have a result and I want to tie a abstract workflow back to that result, I'm going to need more than just the workflow specification. Which, by the way, so if you want to use, I mean, that's basically what these are. These are high-level workflow specifications, but they're not. So I don't know. Well,
none of this is done with specification.
Well, but my point is that so you have to tie your specification. You have to tie your specification back to the inputs and outputs, the provenance in some way, in order to be able to confirm that you have actually reproduced what they claim to have done.
Yeah, yeah.
And so yeah, and that's a limitation of this approach right now. But again, it's going to, there's the how, but there's also the what am I trying to solve? What am I not trying to solve?
Right, and I would argue that these guys the yes workflow guys would say they are not trying to solve that retrospective aspect. But it is a big question about how do you align them. Okay, so
right, but you're not the best workflow people, and you're trying to solve a very specific problem. And in order to solve that, you need to take that into consideration about it. Even you can get something from yes workflow that will do that.
Yeah, I think one you could even challenge the fact that you could say, is this even the right direction? Now, is there even a better? Is there another way to do this? This is one toy that we found, but is there a better way to do what you're trying to achieve? You could have said that.
Well, first I need to know what the problems are.
Right.
But maybe developing use cases, to your point, Jeff, would be the way to try to kind of flesh out that kind of detail, just to better understand how this would actually work.
Right, and so we kind of had two use cases. One is two different approaches to solving the same question on the same data set. And then the other one was giving a methods paper and access to the person who actually wrote the methods paper, try to reproduce the results. And Kristen's with an expert like Kristen. Kristen's failing at the moment.
So there was an interesting, another example of the reproducibility thing. So the Wings workflow people picked a paper, a methods paper from 2010, and they set out to actually reproduce the results of that paper, the analysis that was done in that paper using Wings to document the difficulty.
Yeah.
So essentially, as a vehicle for writing a fascinating paper, do what Kristen's doing.
Right.
But model the workflow that was, and uncover the the little things, and make sure that they were covering all those little.
Well, so when Kristen and I started this work, I said, I want to annotate the heck out of Kristen and her students. Every single thing that you're doing, I want to get down in some kind of declarative representation. And then we'll figure out how much of that we really want to keep and, keep in our representation.
And it's, working with the students right now, it's a challenge because the stuff is I mean, there's just stuff that they do and stuff that they bring into it that's like, where did that come from? And so, anyway, so.
Yeah, let's let John finish.
To wrap it up, some further reading if you care to take a look, posted. And closing note, this came from Kristen. If you're betting your life on this stuff, you better know where it comes from.
So this was actually, this quote, do you remember her saying this?
Yeah.
So the context, there's a lot of different, if you're betting your life on this stuff, you better know where it's coming. And she was coming at it in different ways. When I first heard it, I thought she was just kind of talking in general. Like, if I'm a data analyst that's betting my research on this stuff, I better know what's coming from.
Yeah, but we were also talking about medical.
We were medical
yeah.
devices, medical devices, and that's actually that's really the core of what she was saying. But it was great. It was great quotes I had from these folks. So, any other questions for John? All right. So,
Anyone else and Jim want to start working on the white paper on this?
let's thank John. And once again, so there's no TWed next week, and please sign up for who?
No one.
Yeah, that means no pizza next week. That's what it means. Yeah. But again, I'm expecting everybody to sign up for lightning talks. I'll start setting up those emails almost immediately. And that's it. And thanks again, John. You had to put up with a lot of changes. I don't think I made any changes to the presentation you wanted to present.
I did.
No, actually. Oh, okay. I didn't even catch that.
Oh, I guess I should talk about this. And
thank you both for all your help getting this presented.